My name is Kenton the Tech Pro. Today we are going to be looking at linked lists. Linked lists is a very important data structure that you'll encounter in many coding interview questions. So we have something like this. It's basically a data structure that is made up of items that are connected. So the good thing about linked lists is that inserting items and deleting items takes constant time. So basically, if you want to insert an item, you simply insert it at the end of the linked list, right? So, but when you want to retrieve an item, that is where there is some kind of problem. So the advantage of insertion takes order of one, constant time. There is also this concept of doubly linked list, where the list is linked back and forth. So we have the list is linked back, and also there's also a pointer to the previous list. So this is called the doubly linked list. Now, one thing you want to know about a linked list is that it always has a head. So the head is more like the first item in the linked list, okay? So let's now go ahead to look at how to implement a linked list. There are things you need to know about a linked list. These items in the linked list, they are called nodes, okay? So let's create a Java file and then we actually implement the linked list. Remember, my objective on making these lessons is for you to know how to implement it in Java. So the concept is very clear. You can actually read and understand. So let's see. Let me put it in a folder, src, and then I'm going to put it in a package called coding, and the name is going to be linked list. Perfect. Okay, so this is a class called linked list I've created at this point. So inside this class, I'll have another class that I'll call nodes. So I have the linked list, and linked list is made up of nodes. So let's create this node class, public. Node is simply the data is simply an object that holds the data in the linked list. So remember, you can actually put a class inside a class. Let me see. Public node must be defined in its own class. So, well, check. I think we can actually put a class inside a class. So let me take out this. Okay, perfect. So class node. So let's have next to be the next item in the list. So at this point, next represents the pointer to the next item. So what it means is that we have nodes and we have this pointer to the next item. All right. What else we'll need is the data. Let's say this linked list will hold integer objects. Okay. So we add a little constructor that'll serve as a constructor for creating new nodes. Normally, you have to always have a constructor. In data, and then simply say these are data equals data. Perfect. So we've actually created the nodes, the node object or the node class. So now let's implement the linked list. So as I mentioned before, a linked list will always have a head. So I'm going to create a node head, because the head is more like the handle to the linked list, or like the entrance point into the linked list. So one operation that is performed in a linked list is to append data into the linked list. So append, I'm going to just call it, I'm just going to write it out, append. So to append the data, some nodes or some data into the linked list, you simply need to add it to the end of the linked list. So if you have some nodes you want to add, new nodes, you simply add it, point the last item to the new node. So let's see how we can implement this in Java. All right. So let's start public void append. So it's actually going to be a void function because it doesn't return anything. So it takes the data that we want to add to the linked list. Perfect. So at this point, we now have to get the current node, because normally this is the start of the linked list. This is where it is. So this is a current node. So we are going to represent the head as the current node. So let's say node current equal to head, right? Good. So we now have, we start by going to the head node because that is the first place we are is in the head. So what we are now going to do is to walk through this linked list, checking if we've gotten to the end of the linked list. We are going to be checking if we've gotten to the end of the linked list and checking where the next is null. So what we are going to do is we are going to say while current.next is not equal to, is not null. While current.next is not null, what we are going to do is to advance one step further. So if we are looking at the diagram we draw, so we have this h, we are going to check h.next is simply this pointer. So while this is not null, we are going to advance once, or we are going to reset the current item to this item and then check the next one whether it is null. If it is not null, we simply change the next one and continue until we have a null item. So we say while current.next is not equal to null, we are going to say current is equal to current.next. Okay, so once current, I have to spell it correctly. So once it encounters a null item, it has to fall out of this loop. So at this point, current now does not point to anything. So at this point, while it comes out from this loop, it is at this very point. Let me use a different color. So once it comes out from this while loop, it's checked current.next is equal to null. So what we are simply going to do is to set current.next to the new data we have. So we simply say current.next is equal to new node and we have data. All right. So hopefully this has been clear and informative, and I want to thank you for viewing, but I would like to remind you to subscribe to my channel. And then in the next lesson, we are now going to see how to maybe delete an item from the linked list, or maybe insert an item in particular position, let's say in the head of the linked list. This we are going to do in the next lesson.